the site plan. Again, it shows the location of the project. This is the senior living facility in north of Cincinnati. I don't see a lot of utility information on here. But by the time I get to my grading plan, I can see the stormwater pipes are shown on there, because usually this is grading and drainage plan, so they're trying to help us understand. It looks like all that water is going to end up in that retention pond at the northeast corner of the plan, which I think is plan northwest. So I can get a little bit of that information that I need. But now I'm on my utility plan, so now I can really see the layout and alignment of not only my storm sewer pipes, but my water and sanitary are in here as well. There might even be, it's kind of hard to see, but there's electricity coming off this pole right here into the site. So I can do the takeoff and that. So I get my linear dimensions on here, but my depths, I really want to rely on my profiles to get my depths. This really matters, because when we're putting pipes in the ground, we want to know how deep we have to dig. Because in theory, if you're digging 12-foot deep sanitary sewer, it's going to cost more than a 6-foot deep sanitary, right? We're going to spend more time digging and less time putting pipes in the ground. Really common sense principle. But what also matters is that soil type. So if we're digging through, let's say, real rocky soil, it's probably going to take us longer to dig through that, right, than maybe through a clay soil. So we may not have to worry about over digging, because the vertical part of the trench is going to be easier to do because it's rock. It's going to hold itself in place together. It's going to take longer to dig it, but the trench is going to hold itself in place. If we're digging through a granular or a sandy type soil, what's the problem that you have going through that? It's always going to wants to cave in on itself, because granular material doesn't hold itself together. It's a function of its moisture content and a lot of other things, silt content. So if I'm constantly having to re-dig that trench, that's a lot more digging that I'm going to have to do, but it's also a lot more backfill that I have to do as well. And even if you can use the same material as backfill because it's granular, you still have that much more time. So everything really comes down to a function of time. So I want to know how deep my utilities are. That's a big thing for me, is how deep are they? Because the shallower they are, and the more competent the soil, the faster I can go. These are drawn with a horizontal and vertical scale that are oftentimes different, but it would allow me to calculate my trenching volume, but I can't get my complete trenching information off of here. You say to yourself, yeah, Dan, you can get the length of your trench and you can get the depth of it off the profile. What's the missing dimension? I got length and I got depth. What am I missing? Yeah, the width of my trench. And what's going to impact the width of my trench? The soils. What's the first thing that's going to impact the width of my trench?
Pipe size.
The pipe size, right. And then I've got to leave myself room on either side of the pipe to work, right? I can't have a 24-inch pipe and a 24-inch deep trench. There's no room for a pipe layer to stand in the trench. So I probably need, maybe 1.5 or 2 feet? So I just, whatever my pipe size is, I can add at least 3 feet to my trench, right? So, but that's going to, again, depend on soil type, because if the soil is competent and holds itself together better, I can do that. But if that soil is not competent, and I fear that it's going to cave in, I might put a box in there. Even if it's shallow, I still might put a trench box in it to hold the walls up while I put my pipe in. But if the soil is such that it's dangerous to put somebody in there, if it's deep enough, OSHA says it's 4 feet, right? So if it's deeper than 4 feet, I got to have shoring and I have to have a means of egress. If I'm putting a box in there, now the first thing that impacts the width of my trench is how wide is my trench box. So these are all things that you have to think about. But it really is going to come down to soil type as well. Size of pipe and soil type, because that's going to really inform how wide your trench is. Now there are ways of safely putting somebody in the ground without using a trench box. We can over-dig those trenches, and I'll show you some different trench shapes. The point of all this is that you cannot necessarily get all 3 dimensions that you need off the profile to calculate the depth of your excavation. And we're going to move on to some of these trench types in just a second. So we can measure our length and get the amount of pipe that we have to order off the profiles. That's easy. That's the science part of estimating. That's one of the easy things, is we can get that. If my trench is so sloped that it impacts the length of my pipe because of the slope. I'm probably going to want to estimate my pipe when it's off my profile if I have this. What if you don't have a profile? What do you do then? You can draw your own. I draw a lot of my own profiles to kind of get a picture of what the trench is going to be. The quick and easy thing to do is it's not 100% accurate. You can take the depth of that trench where it starts, at the upstream manhole or catch basin or whatever, water vault, to the downstream structure, and you can average those two depths. That's one way to do it. But that doesn't mean it's going to be that average depth the whole way across. Profiles are better because they show that existing elevation that gives you a better idea. So, anywho, and when you go to buy the pipe, your pipe is sold in different lengths. A ductile iron pipe for water mains is sold in 18-foot lengths. HDPE pipe, which is high-density polyethylene plastic pipe, we normally see it for storm sewer. That is sold in 20-foot sticks, dimensions. So you may end up having to buy more pipe than you actually need for your trench because you might have a piece that requires 2 sticks of pipe, and you're not going to buy 8/10 of a piece of pipe. You're going to buy the whole piece, right? Yeah. So it'll help you get the accurate dimension of how much pipe that you need. Well, let's jump back to the trenching excavation and how we get there. So I want to we'll kind of talk about this a little bit. There are different trench shapes or trench types that we can use to offset the depth to make it safe. And those include straight trenches, wide trenches, V trenches, benched or step. And I'll show you all these in just a second. Or we may have to put a trench box in there to keep things safe. And I've got a picture of that coming up. So, but there's a step-by-step process to get our trench volumes. So the first thing is, and I don't know why it skipped step 1. What the heck? There it is. So first of all, we're going to determine what type of trench do we need. What shape does it need to be in? And that's going to be informed by depth, soil type, size of pipe, lots of those things. Once we know that, then we're going to try to get the cross-sectional area of that trench. What is the area of that trench in cross-section, so we can multiply it by the trench length to get square foot to cubic feet. So once we have feet times feet times feet, we've got cubic feet, and then we know how much excavation we have, and then we also know how much backfill we need prior to backing out the pipe. Those are kind of showing up on my screen here, so it looks right. Okay, so how about if we, and then you're going to need, just like in mass excavation, you're going to need to adjust for shrink or swell. That matters as well, especially on the backfill side. So let's look at some trench types, okay? First of all, the main parts of a trench, the backfill is going to be the bedding, the haunching, initial, final backfill, and then the surface restoration. And the next slide shows that pretty good. So we have the pipe is sitting on some type of bedding. So even if our pipe is shown to be at one elevation, we have to over-dig the bottom of that trench to put the bedding in, right? And the specs might say, set sewer pipe on a 6-inch bed of mason sand or something like that. So that's not going to show up on the profile as an invert. It's going to show up what the invert is, what the elevation of the bottom of the pipe is. So we have to make sure that we account for that overdig. And then that initial backfill right around the pipe that really holds the pipe into place, the engineers call that haunching. And then above that is the initial backfill. So that haunching and that initial backfill will completely surround that pipe and keep it into place. So that haunching and that initial backfill are probably going to be something granular. It's going to be something that you can compact depending on the trench width. It could be a plate compactor, it could be a walk behind roller compactor. They make those pretty skinny. Or if it's deep enough or wide enough, you might be able to get a whole regular size compactor down in the trench. So you're going to put some compaction on it, and then above that is going to be your final backfill. And again, you'll look at the specs to do that. The specs will probably refer you back to the drawing where there will be a typical backfill utility pipe section drawing that is unique to that jurisdiction. Let's say if it's in the city of Cincinnati, Ohio, Even if it's on a private job, if it's under pavement, they want granular backfill all the way to the top. If it's out in the middle of a field, or if it's running across something that isn't got a hard surface, you can probably put the trench spoils back in it as long as they're compacted. So you have to worry about how much trench excavation I've generated, and how much of it you're going to use for backfill. And then whatever's left over, it's going to go someplace, right? Maybe it's going to go to the mass fill in the job, or if it's an export job already, you don't need the trench spoils for the mass fill, you're going to pay to get rid of it. So those are the different components of a typical trench backfill. So we've got bedding, haunching, initial, and final backfill. Okay, any questions about that? The first type of trench is the easy one. That's the straight trench, or the straight wall trench. And it's got two dimensions. It's got a depth and it's got a width. And pretty simple stuff. Now, could you put a person in the ground safely in this ditch?
No.
It's way too deep, 10 feet, right? So what they're not showing is a trench box, because the only way you could do a straight trench at that depth is to have a trench box. It doesn't matter what type of soil it is. 10 feet is too deep to put anybody in, even if it's real rocky soil. You're probably going to want to have some sort of a box in there. So pretty straightforward trench. You wish every trench could be a straight trench, because now you're digging a certain width and a certain depth, and it's simple. But not all trenches are this simple. Most of them are not. So, and the example is the trench cross-sectional area is simply 5 by 10. I got 50 square feet. If I have 200 linear feet of this type of trench, I've got 50 times 200, which is, I can't do math in my head, I'm an estimator, so 10,000. And divide by 27, now I get my raw excavation volume. Pretty simple concept. The thing I love about estimating, the math anyway, is that I don't really have to have been a math major in college. I don't really need to know that much calculus. I need to know some geometry. But most of the math that I use as an estimator, I probably learned it before I got to high school. It's pretty simple. The math is pretty simple. There's a little bit of geometry, a little bit of algebra sometimes that you run into. But I'm not sizing that pipe. And I'm not calculating the escape velocity to put the spatial on orbit. I'm not that kind of math guy as an estimator. I'm taking it and I'm using the basic math operations, the 4 basic operations, addition, subtraction, multiplication, division, and I'm using that to develop cost. I like that about estimating. And even though I consider myself a math guy, I'm not a high-level math guy. I'm a low-level math guy. That's what you need to be as an estimator. So, okay, here, I just had to hit the button that would have done the math for me. So it's on the slide already. I forgot that I put that in there. So, anywho, that's how you do that. So that's a straight wall trench. That's way too deep to put anybody in. We would have to have a trench box for that. Now, one way to mitigate that is to shape that trench. Now, my sides aren't vertical here, right? So now I made a V out of it, and I'm going to make that into some sort of a shape where it's not a straight vertical wall. And now I'm going to worry about what my soil type is, depending on how far back I can make, over-dig the top of my trench so that the wall isn't vertical. That would be a function of soil type. A nice lean clay, you could probably get away with something that's not too expansive. None of that yellow clay or that fat clay, that probably wouldn't be real good. You could probably get away with something like this if it was, a mixture of lean clay and maybe some rock. But again, if I'm 10 feet deep, I've got to have some way to protect the workers in that trench. So I'm going to keep emphasizing that. And again, now the math is a little different. Now I've got my overall rectangle, but now I've got pieces of 2 triangles to do as well. So I'm getting my trench cross-sectional areas, and then I'm going to measure it by however long it is. You guys get the picture. My next trench method is a Y. I've got a vertical piece at the bottom. They show 5 feet here, but if that vertical piece at the bottom is 4 feet, I theoretically don't have to protect that because the vertical component is only 4. But now I've got a bench in there. I've got a 2-foot wide bench on each side, and then I'm going up at some sort of a ratio. So now my math gets a little more complicated. This might work for me. So now my math is a little different now. Now I've got a rectangle, and then I still have, I actually have Actually, I have 2 rectangles and 2 triangles. So I've got four individual things to measure there. And the math is on the next slide. So yeah, I've got a trapezoid, and I can come up with my trench cross-sectional area. All these are going to be the same way. Now I've got a T. Now I've got nothing but vertical components of this. I've got a really wide bench on this. I don't know why we've got 9 feet in here. Obviously, I ripped these off from somebody, with their permission, of course. So, but these are the dimensions that we have. So the bottom line is we've got to come up with that cross-sectional area and then multiply it by the length of our trench. Real simple stuff. Any questions about that? In reality, how are most trenches dug? Most of them are either benched or they're straight with a box. Is anyone going to take the time to dig something like this that's real elaborate? Now, you might if the job really dictates it, but what's the fastest and easiest thing for a contractor to do? It's just a straight trench with a box in it. And let's say your box is 8 feet tall and your trench is 12 feet deep. Now I've got 4 feet above that. What do I do above that? I'm going to lay that back, or I'm going to bench it, but now my extra excavation is minimized because I've got the box in there. But what does the box do, other than keep people safe? How does it impact our cost? I'm sorry?
Rental rates.
Yeah.
Everybody doesn't own them.
Yeah, if you don't own it, you've got to rent it, but what does it do to your production rate? It slows it down quite a bit, because now I am pulling that box forward in the ditch. And what's the right way to do that? Is it to pull it forward? Is it to pick it up and put it back down? It really depends on the job. It really depends on the foreman and crew of the right way to do it. I want to tell everybody a quick horror story. And this isn't really funny because it involves somebody losing their life. But there's a friend of mine in Cincinnati who works for an excavating contractor. He was their estimator when this accident happened. The crew was pulling the box forward in the ditch. They had completed the pipe lane inside that part of the ditch for that length of the trench box. And the excavator went ahead and dug the next 20 feet of ditch. And so they were finished, they backfilled it, they're pulling the box forward, and they were pulling it forward with a chain. I don't know why they did that, but they were doing this in like August or sometime in the summertime, and the operator's cab was open. And exactly what you think happened. That chain was under tension, it broke at the weak link, that link broke, and it came right back up into the cab, and it killed the operator instantly, hitting right in the chest, and it was just like getting shot with a bullet. And it was because they were doing it an improper way. They were pulling it forward with the chain. And they got in trouble for that. And he told me that when all the lawsuits and all the lawyers started getting involved, he had to explain to the opposing counsel what safety methods they took into account in the cost estimate. So they were picking their means and methods apart. They were trying to determine if it was like a willful violation or if it was just an honest-to-God mistake. And I don't know what the outcome of it was, but you have to take safety into consideration. So it might be an OSHA rule now, I don't know, but I know that company at least does. They no longer advance trench boxes with the chain. The best thing to do is just a good grab onto it with a bucket and pull it forward. Most track hose will have a thumb on it now, so you can grasp onto things. And either that or a cable might be a little safer. But that's just a quick little horror story I'll share with you. So, anywho, now I've generated all these spoils. What do I do with them? I have to get rid of them somehow. If I have to truck them off the job site, if they're not needed on the site for any other purpose, now they are adding dollars to my job site, my cost, because I'm putting them on a truck and now they're going away. So, and I may have to pay to get rid of them, but even if I don't have to pay to get rid of them, I might have a free dump site, but I might have to push that off. So now I might have some equipment time. So things to think about. My bedding and backfill materials are definitely something I'm going to have to buy. So those are sold by the ton, but we take them off by the cubic yard. So we have to know what the appropriate weight to volume ratio is. So what do you guys think the good weight to volume ratio, tons to cubic yard, is for, like, to say mason sand? Anybody got a guess? I have a number that I use.
1.5?
Yeah, that's the number I use, Rick. 1.5 tons per cubic yard. But then I'll put a waste factor on top of that. Why do we put waste factors in on backfill?
Lose a lot
Yeah, when are you going to lose the backfill material? You're going to lose it in the transit between the stockpile and the trench as that operator drives that loader over uneven terrain. Some of it's going to bounce out of this bucket, and you're not going to recover this. You got to put some sort of a waste factor in. So that's important as well. My materials, my pipe, I'm going to buy that by the linear feet. If I have to use flowable backfill, I'm going to buy that by the cubic yard. Most ready-mix companies will also sell a flowable backfill product that sets up fast. The nice thing about flowable backfill is it fills in every little void and you're not going to have any settlement. You frequently see that spec in urban areas where you're digging up an existing city street and the authority having jurisdiction doesn't want any settlement, so they'll spec flowable backfill. That's not cheap. I don't know what it's going for out here, but back home it's about 120 bucks a cubic yard. And I'm old enough to remember when it was about 30 bucks a cubic yard, so it wasn't that long ago. And then if I have fittings like bends or Ys or Ts, connections or valves, I want to buy those by the each, which means my takeoff is going to get kind of intricate, because especially if I'm the example that I'll use is if I'm estimating the cost of downspout connections, if I'm hooking up a roof drain system, that's a small diameter pipe, maybe at 10 or 12 inches, usually 6 or 8 inches. But every place that goes up to a downspout connection, I've got a Y in the line, then I've got the line that goes over to connect to it, then I've got maybe 245s, maybe I have a clean out in there. All those little fittings have to be accounted for, and those aren't necessarily cheap. So you got to account for those as well. But I'm buying those by the each. If you have a good relationship, I'll go back to that everybody was talking this morning about having good relationships. If you have a good vendor relationship with a pipe supplier, a lot of times those guys will do those takeoffs for you. So, I mean, if you send them the plans, they'll do the takeoff for you. Now, does that mean that you can trust them necessarily? No, even if you have a good relationship with them, it's not a bad idea just to get an overall count of how many 45s do I have. Because even if you have a good relationship with somebody, they may have had a bad day and they may have missed something. This is, again, part of the art of estimating is how well do you trust people? Because a lot of what we do is we're depending on the information that other people give us to be correct or the truth. And I don't want to get into bid shopping, but we have this conversation in our ethics presentation as well, is when can you be sure somebody's telling you the truth? That type of thing. So, but if you have a good relationship, people will normally help you out and include that in their quote. Bill?
And I think come back and bit me a couple times with thrust blocks.
Thrust blocks, yeah. Tell everybody what those are.
Where a turn happens, particularly in a water line or it's a pressurized line,
yeah,
and you have to push something against the earth to keep that corner because that pressure increases around the corner.
Yeah, it'll want to blow that fitting out. So a lot of times they'll spec a thrust block, which is normally, it's just poured concrete. It'll just back up that pipe. So if you have a thrust block in a water line, you might only need a cubic yard of concrete. But a cubic yard of concrete way out in the middle of the job is going to cost you a lot more than a cubic yard of concrete from when you're pouring the footers.
I was doing a job in Pensacola. We were doing a 48-inch main that had 6 turns in it.
Yeah.
And there was a lot of concrete in thrust blocks.
Yeah, I bet each thrust block was probably 5 or 6 yards.
Yeah.
So that matters. You ever seen one reinforced?
A thrust block?
Thrust blocks were reinforced, where they had to be formed also. So. Anyway, speaking of other things that crazy add cost to your job, other miscellaneous costs can include lumber for shoring if you're going to shore a trench with some lumber instead of a trench box. If you're patching into an existing structure, you're going to have some bagged concrete mix to patch those holes. You're going to have to buy whatever adhesives or lubricants that you need to join pipes together if they're gasketed. If you have restrained joints on a water line, those are what they call mega lugs or things like that. That's a brand name, but now you're physically connecting those pipes with bolts. You're not just gasketing them together. That takes time, slows your production down. But you normally see that where you see thrust blocks on a pressurized line like a water main. Sometimes you'll see those on force mains as well, because those run under pressure as well. But there could be other costs depending on the job. You could have saw cutting, core drilling, disposal fees, water delivery charges. The big thing that everybody forgets about on saw cutting, this is a real thing. I don't know if this is a thing out here, but it is in Cincinnati. The city is really strict about cleaning up your saw cut slurry. Because when that stuff dries, it makes a god-awful mess, and if it gets on something, it stays on something. So they're really big sticklers about making sure you clean up your slurry from your saw cutting. And that could be a second labor on a job, just doing nothing but just hosing down the street. So that's something that definitely adds cost to a job. So. Okay, any questions about that? I have a couple examples of different ways to support trenches or to deal with deep trenches. The one on the right is the more common method. That's a trench box. That's a steel trench box. It looks to be like maybe 6 feet tall. But you can see the trench box is in the ground. They've dug the trench exactly as wide as the box. They haven't overdug that for any reason. And then they're actually digging inside the box to get to the final grade. And then they'll lay the pipe inside the box while the workers are in there. And it's kind of hard to tell, but the top part of that trench is laid back a little bit. I don't know if you can make that out or not, but that's the photo that I found. And you can kind of see that the top part of that above the trench box is sloped back. The second picture is from a project that a contractor client of mine did. This was a big chilled water project at an industrial facility. And the overall trench is about 12 feet deep. And those are 24-inch ductile iron chilled water pipes that you see there. But they've got a vertical component where the pipes hit, and then they really slope that back quite a bit, 1-to-1, to get back. So you can see that the pavement restoration on this, the footprint of the pavement restoration is a lot more than just the footprint of the pipe itself. And you see they've got a jersey barrier sitting on those pipes. What do you think that is for? This was a cost that they had to incur because there was a lot of rain coming. You can kind of tell the ground was rough, but when that trench would fill up with water, those pipes would float. And that was a way to keep the pipes in the ground because the rain was coming after the excavation, after the pipe installation. They didn't have time to backfill it. And there was a previous incident where those pipes floated. And yeah, when the water went down, the pipes went down, but guess what it did? It messed with those joints at the pipe, and the owner wouldn't accept that part of the pipe because those joints were compromised because the pipes floated, and the joints did that kind of thing. So that was an example of the cost that they had to incur. That was a change order, but they wanted the jersey barriers, so somebody had to go get the jersey barriers and put it down. It was maybe $1,500 change order. It wasn't a lot, but it was something that came up on the job. Yes, sir. What's your name?
Craig Nagel.
Hi,
Is
Craig.
there any, I don't know, depth or width that would cause a trench box to become uneconomical and you want to do it a different way, or just a
Yeah, but that's going to be probably unique to a job and soil conditions. So the answer to your question is yes, but it depends on the circumstances. There's not a rule of thumb for that necessarily. I think that's probably more of a function of pipe length than it is pipe depth. Because if you have a whole lot of it, it might make more sense just to step everything back.
Sometimes sheet piling is an option too.
That's a way to do it, yeah. But that's a specialized trade. And you see the example on my left, Craig, there, the overdig? That was mandated in the specs by the owner. They said that's exactly, they had sections at different stations along the pipe alignment, and they showed you the cross-section of the trench that they wanted at each place. So that's why they done it that way. Yes, sir?
Couple of comments. One, you mentioned earlier about figuring your slope and
Yep.
those volumes, and you mentioned about the trench box. Those volumes aren't figured from the top of the trench box. Going out on the slope, it's figured from 1.5 feet below the top of the trench box. Because just like that picture shows, that's actually, there's several OSHA violations in that picture.
Is that right?
Because the spoil has to be 1.5 feet below the top of the box, and there has to be a bench at the top, and I can see there's loose spoil pile even up on top. Because that way the worker's in the hole, if one of those big clods comes rolling down, it doesn't roll into the box.
Are you talking about that pile on the left side?
Yeah.
Yeah, that's a pile of sand for backfill.
But if there's no bench in there at ground level on either side, if there's a cloud of any kind that comes down that slope, it will fall right in the box on whoever's in there.
And that's true, there's nothing to catch it, there's
So,
no,
but it also goes back to just, like I said, kind of tying the two together. There should be a foot and a half
right.
depth below the top of the
You know, that's
box.
interesting, because like I said, these trench sections were, that's exactly how it was drawn.
Mhm.
And the owner had their, I'm not gonna mention who the owner is, but they had their own safety team. They were big enough, they had a whole army of safety people, and they were out there the whole time, signing off on
The
everything.
one on the left looks fine, but the one on the right, ocean inspector tears that one up.
Yeah. That's a good point, I appreciate you bringing that up. So yeah, you have to, as an estimator, you gotta know what the rules are about these different circumstances and situations, because it's gonna be the contractor's fault if there's a violation. Even though the owner drew it this way, OSHA's gonna cite the contractor, the person performing the work, not the owner. If the owner has a role in it, I'm sure they'll have something to say to them as well, but that is a good point. It's our responsibility to know what all the rules are and all the regulations. Anything else about these pictures? I appreciate that, thank you. Craig, I don't know if I answered your question well.
No, it's just case by case basis.
It is, yeah, I wish there was a rule of thumb. Some of us were talking during the break about rules of thumb, and they're nice, but you can't really depend on them all the time.
Some of my coworkers come in and say, well, you got room to open it up, then open it up. If you don't, then.
Yeah. I like the over digging if possible, because it allows the production to go faster. And yeah, you have more backfill to do, but I think what the most important part about all that is getting those pipes in the ground. That's the whole point of the endeavor. So the way I think about it is that the faster you get those pipes in the ground, the better. So I like the benching and the over digging, but that's not to say that there's not a place for the trench boxes. There certainly is. And I'll go back to the point I made a few minutes ago. On most jobs, you're going to see some combination of all these things, of benching or stepping back, trench boxes, lots of different things. So, Mel?
A lot of times you have to take into consideration whether you're using a trench box or open dig is what your conditions are. If you look at the left, if you're responsible for replacing and putting the paving back in, and you're responsible for different aspects of site restoration, the narrower you keep that top, the less you have to pay for that type of stuff.
Right.
Now, where I come from, your point is extremely valid. That box is 18 inches above any surrounding materials, but I can hold it off the bottom 24 inches.
Right.
So I just pull the box up.
Sure.
But they're all accustomed, a good hoe operator can move that box very quickly, very
Right. Yeah.
efficiently. So I kind of look at how big the pipe is, how large my spreaders are in that box versus the size of the hoe. And then you look at what your restoration costs are. You run those two, gives you some sort of
Right.
look to see what the differences are.
Mel just mentioned the spreader bars in the trench box, and those are those horizontal bars that go that way. Some people call them spreader bars, some people call them braces. But I think the best way to do this, and this really comes down to the skill of the operator, I mean, you over dig that thing just enough that it's going to easily slide. Not so much that it's going to make you spend a lot more on backfill, but if you over dig it just enough so the box isn't completely tied up against there, it'll let you pull it forward. But if you, but in any event, if something starts to cave in, that box is still going to catch it. And I'm talking about inches here, like baseball. It's a game of inches. You know, it's just a maybe even a couple of inches wider. That would still protect the workers, but allow the box to be a little more easily moved. I think my buddy's company probably dug the thing just as wide as it needed to be and not any wider. And sadly, it had a tragic result. So, okay. Thanks, guys. It's a good discussion. Let's talk about the equipment that we're going to select. Of course, we're going to be digging with something with a power shovel, a track hoe, or a backhoe, that type of thing. I've worked on a lot of city Cincinnati water main projects, and you're always working on existing hard surface pavement, and the city won't let you put a metal track machine on one of their streets. Even if you're going to mill and resurface it, they want to see a rubber track machine on there. So you see a lot of the contractors going with these equipment spreads that are these smaller track hoes that don't have to have the real deep digging capacity. They'll still dig 10 or 12 feet deep, but they're rubber track, they're lighter, and then instead of having a big rubber tire loader, you see a lot of these really beefed up skid steer loaders on these type of urban projects where you're working on existing pavement. So anyway, those job site conditions and sometimes the owner's requirements are going to help inform what type of equipment we're going to use. We also want to make sure that we have enough horsepower to dig through the type of soil we expect to encounter. So, we're not going to dig that 20-foot deep sanitary sewer with a bobcat with a backhoe attachment on it. It's just doesn't have horsepower. We're going to have like a Caterpillar 330 maybe a 320. Something that's got enough horsepower. But what's the other thing that we're doing with these track hoes? We're not just using them to dig. What else are we doing with them? Yeah, we're using them as cranes. So they got to have the lifting capacity to set pipe and precast structures. So that's going to all inform the type of equipment that we're going to select. And I've got some pictures coming up. When we get on the backfill side, now we need something with a bucket that we can, shuttle material from a stockpile to the trench itself. But it's one thing to get it into the trench, then we've got to grade and compact it. So a lot of times you'll see the track hoe involved in the backfill operation because they are spreading it. Because you don't want to put a lift of backfill material in that's 3 or 4 feet thick and you try to compact that because you're not going to get any good compaction. So the engineers, they're going to want to see a thin lift, somewhere 6 to 12 inches of a thin lift like that can easily be compacted with the conventional piece of equipment. So in backfill, we're going to usually see some sort of a skid loader, a rubber tire loader, sometimes a rubber tire backhoes. You don't see too many of those in job sites anymore, but they're still out there. And again, the width of our trench is going to inform us about what kind of backfill or what kind of compaction equipment we're going to use. So I have in the picture here examples of several things. I've got 3 loaders, 1 track hoe, and 2 different compaction methods. And the one on the top middle, that's a conventional roller. Your trench has to be pretty wide to get something like that in it. But a lot of these manufacturers will make walk-behind machines that you can put somebody in, and they're like drones on the ground. They're operated remote control, where they're only wide enough to get in the ditch. You got to lower it in with the backhoe. But sometimes you have to put a person in the ditch with a vibrating plate compactor, and that's what the bottom middle picture is. So these are some of the different types of equipment that you're going to use, or that you're going to see on site utility projects. Am I leaving anything out? Pretty simple concept, really. I'm digging a hole, I'm putting something in it, and then I'm covering it back up. That's the simple explanation. The more complicated explanation that we are trying to deliver as estimators is what is that going to cost? And there's all these different things that go into it.
Are there any, if you're reading the specs for backfill compaction or anything, are there any specific words or items to look for that are kind of gotchas?
They may actually specify the type of backfill or compaction equipment you have to use. They may say we want, I don't know, 25,000 pound machine or something like that. I've seen specs that are written that way, but most specs are just going to say provide compactive effort to achieve the densities that are required for that material. So they're going to leave it up to you as to what equipment to select. Now on the earthwork side of things, I've seen equipment sizes spec'd out as a minimum for what defines rock on a job. They'll say that if a piece of equipment the size of a 330 Caterpillar machine or equivalent cannot excavate this material, then it's rock. Anything above that, or anything below that, it's not rock. It's what they call unclassified excavation. And you got to eat it, whatever that is. So I have seen that spec before, where they tell you that either the horsepower or the operating weight, or they'll give an actual model number of a piece of equipment. That's a good question, and I'm going to kind of segue a little bit. One of the best sources of information for earthwork and site utility estimating is the equipment handbooks that the manufacturers put out. John Deere and Caterpillar and Komatsu, they all publish these catalogs once a year, and they have so much information in them about each piece of equipment that they manufacture. They'll put lifting capacities, and not just lifting capacities, you know, when you're hovering right over it. They'll give you the lifting capacity when the boom is extended 20 feet, because it's going to go down as you go further out. And they'll give you fuel consumption. So those are really good resources, and those are downloadable and free from the website. And it's just a resource that if you're in the equipment or the earth moving or utility business, it's a good resource to have. Of course, what are most contractors going to do when they're bidding the job? What equipment are they going to rely on to put into their bid? What they already own, right? Yeah, they're, you know, is it possible that a contractor is going to go out and buy a piece of equipment specific for one job? Probably not. You're probably going to try to recover that over the cost of several jobs. But if there's something that's unique or particular about a certain project, it may behoove you to go rent that product or rent that piece of equipment just for that job, because it'll make everything else go faster. It might just make life go a lot better just by renting it. Then, of course, as the estimator, you want to make sure you cover the cost of that rental. How do the rental companies make money? By charging you a lot more than you would pay yourself if you bought it. That's how they make their money. So, and if they have it long enough in their fleet and they keep renting it and renting it, it just gets paid for over and over again. So generally, it is better to own a piece of equipment than to rent it. If you rent it from yourself by owning it, when you're finished with that piece of equipment or it's just got no life left, now you've got something that's either scrap, salvageable, or something you can trade in. It might still work, but now you've got something. It's like buying a house. You've got some equity in it and that piece of equipment. Okay, we've got about 15 minutes left, which is good. So let's talk about labor classifications. Of course, we're going to have operators to run this equipment, but we're also going to have the pipe layers and, of course, common laborers as well. So, and we may have some other classifications depending on the job. If we're in an urban area or working in the street, we're going to have maybe some flaggers. But the flaggers are probably going to be paid at a laborer's rate. It just depends on if it's a PW job or not. Everybody understand what prevailing wages are? Okay, all right. The pipe layers are the ones that really make a difference on a site utility job. These are skilled laborers. They've got special knowledge of how to join pipes together, how to put fittings together, and they can do it fastly and safely. They're used to working inside of trench boxes, and they are the key to getting the pipes in the ground. So that's not to say that a couple of smart laborers couldn't do it, but I'd much rather have a couple of skilled pipe layers on my crew doing that. The laborers are going to do things like back trucks and under the hoe, or flag traffic, or they'll spot loads of granular material along the alignment of the pipe, far enough away from the edge of the ditch. That's important. And what was your name?
Gerald.
Jerome?
Gerald.
Gerald. Okay, Gerald brought up. If you're placing your spoils on the cut bank, they have to be far enough away so they don't easily fall back in the trench. Same thing goes if you're spotting backfill material along the alignment of your pipe. But you're probably going to have a laborer spot those trucks and do that type of thing. So, okay, any questions about that? Okay. And then, again, this is just the cost estimate one. This is the art part of estimating. This is getting that production rate right. So we want to know how much our crew can do in a given set of time, either per hour or per day. And it's going to be unique to this particular job. You're not going to get the same production on every job, every time, because the characteristics of the job change. The deeper your trench is, the slower your production is going to be. The more you have to use trench boxes or shore the trench or over dig, the less time you're actually putting pipes in. Those are the sorts of things that drive the cost up, because your production rate slows down. And again, you're never going to have the engineer tell you what the production rate is. You're not going to find it in the spec book or anything like that. That's going to come from your own intuition. That's where you want to go ask the people that work in the field. Hey man, we're bidding this job and I could really use your help. How fast do you think we can go? And they'll remember some job they did 4 or 5 years ago. They said, you know what, we had this problem, but same size pipe, same material, same engineer, and we did like 180 feet a day. That might be a good starting point, and then you run the math on 180 and see if it works. And if that's not working, you know, maybe you do a 150, and you keep playing with it until it gets right. That's why I like Excel so much, that you can do a lot of different flexible things with the cost estimate. So here I you know, just give you an example. I've got, it turns out my production rate is 120 feet a day, and that's, you know, 2,400 feet. The math is real simple. I get 20 days worth of work. So now you can have different tasks into that one activity of laying the pipe. You can separate out the trenching from the pipe laying, from the backfill. You could have a production rate for each one of those things. That's perfectly fine too. Just depends on your method of doing it. So again, the production rates are highly variable. They're impacted by a lot of different things. Soil type, even things like how far am I from the disposal site? If I'm digging and loading into trucks, how fast are those trucks going to get back? What's my cycle time? The dump site's far away, you got to have more trucks to do your job. Otherwise, your hose is just going to be sitting there. That's not good for anybody. If anybody's ever worked for a paving or utility contractor, there's nothing that's more frustrating than having your trucks get caught up in the very traffic jam that was caused by your own lane closure. It's ironic, but you get punished for doing your own work. So anyway, we all know as estimators that we want to rely on historical cost data, and we want to know as much as we can about previous jobs. So that's important. So when we talk about labor and crew, I call these crew compositions, and some jobs need bigger crews than others. It just depends on the job. There's a lot of things that go into that selection of equipment and people that make up how you're going to do that job. I wish there was a rule of thumb that I could say, hey, every ductile iron water pipe under 12 inches needs 6 people. It's just not that simple. You got to look at every job like it's its own thing, which to me makes estimating really interesting, and that's, again, the art part of estimating. Okay, and then lastly, I do have a sample cost estimate, and again, this might be kind of hard to read, but I'm not putting any pipes in the ground, I'm just trenching in this episode. So I've got my quantity up there. I do list the size of my pipes. In this case, I'm trenching for different size. I got a different production rate for each size. I'm 125 feet a day for the 48-inch pipe, and I'm 150 feet for the 12-inch pipe. And so I calculated those days in. This was for a really big job in Pittsburgh, and the owner wanted the trenching and the backfilling and the pipe lane all estimated separately. So that's why I did it like this. So, and you can see I came up with a linear foot price of $101.11. That's just my raw cost. I don't have any markup or anything in here. But again, I like to put all my costs into the 4 different classifications: labor, equipment, materials, and then subs or incidentals. And I like to track this down here. I like to see what those percentages are, because over time I've developed my own rules of thumb. If my cost estimate comes out within those percentages, I feel like I'm pretty close to being right. It doesn't mean I won't change it, but that's just one way to do it. This is from Excel. If anybody wants to see a copy of this, I can be more happy to give you that as well. You just have to ask. So. Now, we have 9 minutes left, and last session we got done late. So this session we're getting done a little bit early through the material. And that's okay, but we have a little more time for Q&A. So Q&A, discussion. What have I not covered here? I really haven't talked about using any particular software. And the reason I don't use a cost estimating software is because my clients are so different. I have everything from engineers to construction managers to small subcontractors. And they all want things done a little differently. So flexibility-wise, I like to use Excel. But if you have something like HCSS or Niche or one of some of the other programs, you can set those up to customize it to you. Trey, what's your question?
So when you win a utilities package, how do you handle the relationship with the Mass X guy when it comes to your haul off, if, say, he needs to import?
Well-
You're pulling out,
Right,
and if you have excess,
yeah.
it benefits him.
This is why it's a good idea, even if you're not bidding that part of it, have an idea if this is a field job, or an export job, an import or export job. So if you have an idea, you may even want to initiate the conversation before the bid goes. If you have an idea, a relationship with that earthwork contractor and say, hey, we got 4,000 yards of spoils coming off the trench, do you need that for your field? Do you want it?
So you just allow him to take that and
Well-
you don't ever touch it again?
Well, I still think you're gonna have to transport it because you don't know where they're going to be on the field at that job. 'Cause you just can't coordinate that far ahead of time. But the upside to you is you're still putting it on a truck and taking it someplace, but you might only be taking it 1,000 feet across the job site. That's a lot cheaper than taking it 6 or 7 miles and paying to get rid of it. So it doesn't, that's where a good relationship comes in with somebody. Or even if you don't know them, as soon as you find out you got the job and they got the job, start a relationship, because those two things are going to interact for sure.
A lot of times in the funding documents, the general contractor is specifying the scopes of work, what to do, and I often did that. Everybody
Right.
gets spoils in one spot, and the earthwork guy gets them, and then they have to get together.
Right.
At least you know what you're doing
Yeah.
in front.
Yeah, you see that on a lot of CM type projects where I know Turner's really good about writing good scopes of work for each package. Some of their estimators are better than others. Sometimes they leave things vague, but if they get real specific, they'll very issue because they'll know themselves. This is an import job, and the less we have to import, the cheaper it's going to be to the owner, and the cheaper they can be as well. But that is a good point. It's a really good question. If you know you're going to have spoils to get rid of, I'd much rather leave them on site than haul them off the job.
Because it would sure suck if you didn't get to put your utilities until the mass X was done. He had to haul in all that fill,
Right.
then you have a bunch of excess
Right.
that dug it up.
And you can have the same problem if the phasing doesn't let you do that. I've been on projects where the owner wants the building pad ready, or the GC wants the building pad ready, or the CO, at a certain date, because they want to start digging footers and setting precast or whatever. But all the cut that you need for the building pad is coming from something that's in the next phase, or 2 phases away. So you need all this fill for the building pad. You need it now. You can't wait to dig that pond in your final phase. So you may have to be importing fill before you get to the part of the job that generates the fill that you need. But you just have to understand the sequencing and the phasing. It can be a little tricky. You got to understand the operations and how things are going to go. And to me, that's just what makes estimating so interesting, is that you got to be tactical that way in your thinking.
That's why I really enjoyed working for a site utility contractor. We used AgTech, but what I ended up doing was I modeled the site, all your building pad excavation,
Right.
all your site work.
Even if you weren't getting that part of it?
Even so, because that was part of how we generated how we were going to phase our work.
I see. Okay.
So, but we did do site, the whole site excavation plus,
Okay.
some of the trenching and stuff too, so we worked a lot into it
Right.
as well.
Yeah, there are spoils that will be generated that don't come from utilities also, like footer spoils, and if you have retaining walls in a job, especially modular walls, a lot of those will require, pretty wide swaths of granular backfill behind the walls, and that's a lot of extra digging that you may have to do. Or if those walls are holding up fill, that's that much less fill that you need. And if you're savvy, you can leave that amount of fill out of it because you know the wall contractor's going to put that in. So why put something in your bid that somebody else is going to cover? And that's the kind of strategic thinking that you have to do. Good discussion. Somebody have a question over here? Yes, sir.
You said you had your own rule of thumb for labor, equipment, material.
Yeah.
Can you share those?
Yeah, they're pretty much what you see up there. This job had no materials because it's just a trenching exercise. But if my equipment is going to be someplace a little bit less than my labor on this, and my labor is the biggest chunk of it. I've got almost 22%. So I'm expecting my labor to be at least 20% and my equipment to be somewhat less than that. So I don't really have any hard numbers, but if this number is higher than this, then it makes me want to say, okay, why is that? And there might be something about the job you're not normally gonna see that on a site utility job, but on an earthwork job, those numbers might be flipped, because you can move a lot of dirt with a piece of equipment without having somebody on the ground watching it. So you might have 4 pieces of equipment, but you might have 1 laborer assigned to that. So your labor costs are gonna be relatively inexpensive compared to your equipment. You got 4 dozers and scrapers working. Yeah, they've got operators on them, but you don't have you don't have an equal ratio of people to equipment, and the equipment costs a lot more than the people do. So it just depends. But I do like to pay attention to that stuff, because it just helps you know if you're in the right ballpark or not. It doesn't mean that you're wrong if you're not in that ballpark, but there's probably a reason for it. And you want to ask yourself those questions before a client asks you the questions, or your boss asks you those questions. This is estimators, we want to have an explanation. Every decision we make, every number we come up with, every conclusion we arrive at, we have to explain to somebody. Someone's going to want to know, where'd you get that number? I've been asked that question a million times. Or if I use, and it might not even be a number thing, it might be a nomenclature thing. I usually have a line in there called MOT. And I have general contractors that call me right away every time. What the hell is MOT? What's MOT? You guys all know.
Is that like a swag?
No? No, but we'll cover that next. It's maintenance of traffic. And if I'm working in the street, I gotta have flaggers, I might have to have jersey bearers, I need to have barrels. That's my traffic control. So tell everybody what a swag is. Everybody in this room knows what a swag is, right? This one you guys know. What is this, G? A guess? What kind of guess is it? The guess is the G. So it's some sort of wild ass. Yes. What's the S?
Stupid.
Stupid? Okay. Sophisticated? But you know what? And I say this in all my classes, that we cannot predict with 100% certainty what a job is going to cost. Nobody can schedule a job with 100% certainty how long it's going to take. Nobody can predict with 100% certainty that this is going to happen or that's going to. We are estimators. We're not exactimators. We're trying our best to get it right. What's the popular phrasing now for the work that we put out? It's not estimate. What do they call it now? It's an opinion of probable cost. Doesn't that just sound like some sort of BS kind of thing? It's an estimate. We're estimators. We estimate. So we're trying to get it right. And Mel told the story this morning about being at a bid opening and watching the faces as the numbers over there. You know, and that's, to me, that's always kind of the drama. So many bid openings have gone electronic now that you kind of lost that human drama, watching the guy who's read low and then watching his face. And if all the other numbers are real high and that low guy, he's sitting there praying for somebody to be lower than him. And it's always great drama just to find out, because you don't know what somebody was thinking. You know, how many times have you heard a bid result and said, how the hell could they be that low? There's no way I could be that low. Gosh, the cost of my materials is 80% of that. You know, so you're always scratching your head, but somebody has to explain to somebody how they came up with that number. Is the low bid always the best bid? No, and how do we make owners convinced of that? You know, how do we get them to look beyond that bottom dollar? So that's always a neat trick as well. It goes back to your point about educating them. The lowest bid isn't always the best bid. Isn't it a little risky to take the low bid?
I was gonna say, give them lots, like, you know.
Yeah. Well, I know, but a bad bid can be an expensive lesson, even for an owner. You don't want somebody with a really bad mistake on your job. What is that contractor more likely going to do, or be more tempted to do? Gee, shortcut. They'll put 6 people on a crew that calls for 12 people, and somebody's going to get hurt. That's not good for anybody. So I'm not a big fan of the low bid, but and it's not even, the owners always have a clause up in Division 0 about what kind of bid they'll accept. They don't use the word low. What word do they use? Well, the word, they do, but the word I was looking for was responsible. They'll call it responsible. And that's, you know, what makes it responsible bidding. So,
I was just gonna suggest the difference between the unit probable cost in the estimate is actually where you are in the process.
Right, yeah, what phase of design is it?
Yeah, because I work for like an owner side, and so I was telling him, like, this is my opinion of probable cost, but you're not gonna have an estimate until you have plans and specs.
Right, yeah, until your design gets past DD, when you've got something you can really work with.
Yeah.
So we really didn't talk about that today, levels of design, and this is based off of, this is actually based off of the SD set of plans, but they were pretty well developed, I can do a pretty good takeoff. So, on this particular one. Okay, that's good. We're already late for lunch, and so it's out there somewhere, and we will see you guys later on throughout the day. Thanks, everybody. Oh, here, my digits are up on the screen if you want a copy of anything.